Hello, students. Welcome to Distance Learning Lesson 7 of Unit 11. This is IXL U3, which is arc length. So we just did a lesson on area of, we did area and circumference. And now the question is, if area and circumference wasn't the whole thing. So imagine that I was just looking at maybe this edge. Okay, what if I want to know how long this is, but not actually be the circumference? Okay, so that's what we're going to be studying right now. We can also find this one. What we need to focus in on are two things. Um, we need to know how long the radius is, and we need to know how many degrees the arc is, or the central angle, and in this case, both are 135. Central angles are actually equivalent to the arc that they intercept. So take a look. If I extend these out forever, this part right here is the same measure as the inside. So we need to know that measure, and we need to know the length of the radius, and we can actually find, the arc length of that arc. So here's what we're going to do. The circumference formula, circumference is 2 pi r, okay? But the arc length formula is 2 pi r. It's the same thing as circumference, but we have to do something first. We have to multiply this by what's called theta over 360. So theta represents my angle, and 360 represents the total degrees in a circle. If I were to say to you, you have one pizza, and it's cut into 8 slices, if you eat one slice, how many have you eaten? You would say 1 out of 8. Well, if you were to take the 360 degrees that the pizza makes up and you divide it by 8, you get 45 degrees. So really what you did was you ate 45 degrees out of 360 degrees, which is really the same as saying 1/8. So it's already in simplest form when you write it as 1/8. So what we're going to do for all of these is do theta over 360, and then we're going to multiply it by the circumference. And that's the only difference. So for this first problem, we have radius is 3, and we have the degree measure is 135. So let's actually do the math here. Arc length equals 135 out of 360 degrees times 2 pi, and we have 3 feet. All right, now 135, what we're going to do is we can either try to simplify this before or after. I think sometimes before is better. So what is 135 and 360 both divisible by? Well, I think they're both divisible by 15. Let's see, 360 divided by 15, 24, and 135 divided by 15 is 9. Oh, you know what? I think they're divisible by more, but let's see. Arc length is equal to, looks like 9 over 24 times 2 pi 3 feet. I can simplify it maybe a little bit more. Looks like I can divide both by 3, so I get arc length is 3 over 8 times 2 pi times 3 feet. Okay, and now this is a little bit more easy to manage. So let's multiply all the numerators. So 3 times 2 times 3, so 3 times 2 times 3 is 18 pi feet over 8. So what I did was I took 3 times 2 times 3 times pi times feet. So it was all ended up in a numerator here. And 18 divided by 8, well, we can simplify that to become one last time divided by 2 and divided by 2. So we're going to factor out a 2 from a numerator and denominator, and we are done. And there you go. Okay? So that's my thought process, is to try to simplify your degree measures first. Degrees divided by degrees goes away, right? So these will go away. So you don't even really need to write them. And then we simplify the rest. Now, some students might find it easier to instead do this alternate version, which is to do 135 times 2 times 3. And that's fine. You get 810 pi feet over 360. And then you have to simplify from there. Okay, so 810 pi over 360. And it looks like they both will have 90. So 810 divided by 90 is 9. So 9 pi feet. And then 360 divided by 90 is 4. So this one was quick. I mean, these are two different ways to do it. Sometimes they'll be quicker. Some will be quicker than others. Okay. So that was just two separate strategies. So I'll write strategy 2 is in red. So arc length equals, it's really up to you. Do you want to just multiply across, or do you want to, do you want to multiply across, or do you want to simplify and then multiply? Okay, you want to make sure you enter as a fraction. You can put pi in the numerator or leave it on the edge of it. So 9 over 4 times pi. You just can't have pi in your denominator. Okay, so it's going to be in the numerator, either in the numerator or attached. Okay, the next one, you have a diameter. So it's the same formula, except you need to knock out this diameter. So you're going to have to write, it has to be in radius form. So we're going to knock that out, write 3 miles. So radius equals 3 miles. So radius equals 3 miles. So yeah, we have 3 and 3. I'll label those because those are making up the 135-degree angle. Whoops. Yikes. Oh, you know what? I didn't know that these both have 135. We'll have other problems. They don't have to have 135 degrees. They can be anything. As you see in the next one, it's not 135. Well, we don't know what it is because we're going to be solving for that angle. But let's do the arc length here. So we're going to do arc length equals theta over 360 times 2 pi r. So arc length equals 135 over 360 times 2 pi times 3 miles. Because I've simplified it up top, I know what it is, but let's just multiply across. Let's simplify it after. That's a different strategy. So 135 times 2 times 3. So we get 1,620, 16, wait a minute, no, 135 times 2 times 3, 12 times, yeah, 16, 20, did I do that one above, right? Yep. What did I do wrong? 135 times 2 times 3 is 810. Yes, sorry, I did too many twos. Yep. Okay. So we have 810 pi over 360 miles. And you know what? This one is the same exact answer. I'm sorry about that. Each is divisible by 90. So I apologize. They do differ, so you're going to have to simplify them differently. Okay. They're not all going to be 135 degrees. All right. But we can, I think you get the point of it. Just make sure you get a radius and that you use theta over 360. So this one, whoops, this one is this one, you don't know what your angle measure is. You don't know what theta is. So you're trying to solve for it. So we're going to do arc length equals theta over 360 times 2 pi r. And we don't know what theta is, but we do know that the length, it says the radius is 12 inches. What is the angle measure of an arc 3 pi inches long? So it looks like they gave me that this is 3 pi inches long. So we're going to substitute that piece in for right here. So 3 pi equals theta over 360 times, and my radius is 12, so 2 pi times 12. So I get 3 pi equals, now bear with me, I'm going to combine it all. I'm going to get 2 times 12 is 24 pi. Oh, 24 pi theta over 360. And so to solve for theta, I'm going to do a couple things. The first thing I'm going to do is to multiply both sides by 360 to get rid of this denominator. So 360 times 3 is 10,080. 1,080, sorry. So 1,080 pi equals 24 pi theta. And this is all multiplication. So now I'm going to divide both sides by 24 pi. So I get theta equals pi divided by pi goes away. So I get 10,080 divided by 24, which is 45. So theta equals 45 degrees. So the answer would have been 45 degrees. So what we did was we worked backwards to find what degree measure would have to be here for that arc length to be equivalent to 3 pi, given that we have a radius of 12. Okay? The next problem, we have a diameter of 10. It's the same thing, but we're going to work backwards. But we got to knock this out first and make it a radius of 5 meters and a radius of 5 meters. Okay, so we're going to work backwards. We're going to do the same thing we did here. So I'm going to just copy that over here. Our arc is only pi meters long this time. It's not 3 pi. So we're going to have pi meters times equals theta over 360 times 2 pi times 5 because the radius is 5. So I have pi equals, let's clean it all up. 2 times 5 is 10. It's going to be 10 pi theta over 360. By the way, theta is a Greek letter, so I keep saying it over and over. It's a circle that has like a little line through it. Okay? So we are going to now multiply both sides by, what did I use? I used red. Okay, pink, I mean. Okay, multiply both sides by 360. So we have 360 pi equals 10 pi theta. And then the last step is going to be to divide both sides by 10 pi. 10 goes away, pi goes away, pi goes away, so I get 36 because 360 divided by 10 is 36. So 36 degrees equals theta. So theta equals 36 degrees. And we are done with that one. So let me just box this. We got that one boxed, we got this one boxed. And there we go. Okay. The last two are word problems, really, that's all. We're going to do the same thing, but it gives us a radius and it gives us our arc length. So here's a radius. Radius is 35. And the arc is 7 pi miles long. Okay, so we are going to, whoops. I should have did that backwards. Oh well. Yeah, let's change that up real quick. So a radius of 35 miles. And a arc length of 7 pi miles long. Okay. So, yeah, that's not going to help me either because these are not. Okay. So it looks like we have, 7 pi. So 7 pi equals 7 pi equals theta over 360 times 2 pi times the radius, which they said was 35. So we get 7 pi equals 2 times 35 is 70. So it's 70 pi theta over 360. So first thing I'm going to do is multiply both sides by 360. So 360 times 7 is 2520. 2,520 pi is equal to 70 pi times theta. And the last step is to divide both sides by 70 pi. So that goes away, that goes away, that goes away. So 2520 divided by 70 is 36 degrees. And we are done. 36 degrees. Ironically, same as the answer we got for the last one, 36. Okay, just the same process over and over again. And let's see, whoops. Let me pull this again. So we have 5 pi inches long, and we have a diameter that is 16. So let's be careful though. Hold on. Diameter is, let's see, diameter is, oops, I want to change that color. Diameter is 16 inches. So be careful. You want to first, if diameter is 16, then radius is 8 inches. So we want to use 8 when we're doing this problem. So we have 5 pi equals theta over 360 times 2 pi times 8 inches. So do the work out. 5 pi equals theta, sorry. 2 times 8 is 16. Oh, you know what? Let's get rid of the units. We don't need inches because we know that there's inches on both sides and that they would go away when divided. So 2 times 8 is 16. So 16 pi theta over 360. So multiply both sides by 360. Notice there's a pattern every time we're doing this. So 360 times 5 is 1800 pi. So we get 1800 pi is equal to 16 pi times theta. Last step is to divide both sides by 16 pi. This works out really nice. 16s go away, pi go away. So 1800 divided by 16 is 112.5 degrees. Because everything else goes away. Let's see. I want to make sure I did everything right because I'm getting a decimal. And it looks like the answer is needed in a fraction form. So hold on one second. Diameter is 16. Radius is 8. So 8 times 2 is 16 pi. That worked out. 5 pi inches long, so 5 pi goes there. So we multiply both sides by 360. So 360 times 5 was 1800. We divided both sides by 16. We got 112.5. Now, I think this would mark you wrong, maybe. No, it should. As a fraction, it's if you put it over 2, it's 225 over 2. But I don't normally see degrees that way. Normally degrees are decimals. So let's just say that it's 112.5 degrees. And I will update you because it isn't exact and it is in simplest form. So I think it's good to go. All right. Yeah, I don't think that they would do a fraction for degrees. Okay. That's it. So you are working on, for this one, U3, which is arc length. All right, good luck.